We're going to give a demo today of the Fluke 830 alignment tool with the demo rig. When we open up the case, you'll notice the quick reference guide, and the quick reference guide takes the user through these step-by-step points. In the case, you'll see three parts of the 830. The 830 computer, the laser sensor, and the prism bracket assemblies. We'll also use the 830 PC display software to show live screens of the 830 during the demo. Looking at the demo rig and showing it to your customers, the left machine is the stationary and the right machine is the movable. Stationary would be the pump. And if you think of a pump with its piping, it's not movable, but the motor is movable. The first step, we're going to go through and put the brackets on the machine. When you set up the alignment tool with the demo rig, the laser is on the left from the audience's perspective. We mount it as low as possible, but high enough for the laser beam to clear the coupling. On the right, we mount the prism the same height as the sensor. After connecting the sensor and the wireless module, we switch on the wireless module, and the switch is on the back of the panel. We'll notice the lights turn on that powers the laser up. We're ready to take off the cover and start our alignment job. Turn on the 830. It will come up automatically on the setup screen. We're going to measure the machine dimensions and enter them into the screen. The first dimension is the measurement between the sensor to the prism. And on the top of the sensor and prism, there are some marks that we're going to use for our reference points. So we're going to measure the distance between those two marks, and then we're going to enter that number into the 830 screen. So our next step is to measure the sensor to the center of the coupling. Notice that as we enter each of these steps and press enter, the 830 automatically advances to the next step. Our next measurement is going to be the coupling diameter. We're then going to go and enter that number into the 830. After coupling diameter, we advanced to the RPM of the machine. This is just a nameplate RPM to be used in the tolerance tables, because faster RPM machines will have closer tolerances, slower speed machines will have wider tolerances. After the RPM, we then measure the center of the coupling to the front foot of the right machine, the motor. This is where the adjustments are going to be made. Next, measure the distance between the front foot to the back foot. We adjust the feet, and as we adjust the feet, it brings the shaft into alignment with the stationary machine. After we make that measurement and press enter, the 830 automatically advances to the next step, which is the measurement. Now we're ready to make a measurement. When we look at the screen of the 830, we'll notice that the laser is ready, and we'll notice that the prism and sensor are at the top of the machine. And we want to rotate it in the direction of the rotating shaft. So whatever position we start with, and we try to rotate 180 degrees if possible. So for example, if we start at the side at like 3 o'clock or the 9 o'clock position, then we can rotate all the way up to the 12 o'clock position and then the next position. So let's start down at a 3 o'clock or 9 o'clock position. Notice that the built-in inclinometer is going to automatically tell us what position the device is on. When it turns green, we press the enter button for a measurement, and then it turns orange or amber. As we rotate it to the next clock position, notice that again, it will turn green. We'll take a measurement, and as that measurement is done, which takes only about a second, then that sector will turn orange, and then we rotate it to the third position. When we make our last measurement and the final sector turns orange, the 830 will automatically advance to the diagnose screen. In the diagnose screen, this is where we're going to see the alignment results, the conditions, and the foot condition. If we were to blow this up a little bit more, you can see there's actually 3 pieces of information here. The first piece of information is the misalignment values. Notice there is vertical values, gap and offset, and horizontal values, gap and offset. These are the physical dimensions or misalignment of the coupling at the coupling center. To fix those, the correction is at the feet. Also notice there's an alignment condition. Based on the tolerance tables, we're going to know whether our misalignment is grossly misaligned, out of tolerance, acceptable, or excellent. And then the last part, which is probably the most important, and that's the adjustment values. Notice there are vertical adjustment values and horizontal adjustment values. So once we find some misalignment, we need to correct it. We loosen the bolts and we shim in the vertical direction. Now for demos, we're going to leave this aligned vertically, but to correct the misalignment, we would jack up the machine and insert and remove shims. Make sure that we do our foot corrections on both of the motor front feet and the motor back feet. Negative values means we need to pull shims out. Positive values means we need to put more shims in. So we add shims for the vertical movement and we move the machine left to right for the horizontal movement, and that will make the corrections. Now we're going to go to the horizontal move. We do that by going to move, and then we'll see that a screen pops up that tells us to position our sensor in one of the 45-degree positions. We select horizontal, and then we get a live horizontal move screen. We can make our adjustments live, so we're going to watch the color-coded tolerance bar, and as we move the feet back and forth, once we get into the green, then we're going to stop. We're going to tighten the bolts down. Green is an excellent alignment. Yellow is still okay. It isn't unless you get orange or red that you need to start over again. We're careful as we lock down the jacking bolts and we probably want to do it in a cross pattern, because if we tighten it down too much one or the other, we'll knock ourselves back out of alignment. The final step is we could do another measurement at the end to make sure that we've aligned this machine. Then we would print a report, and that report will be used to document that we've done a good job and the alignment is done.